Welcome everyone. This is episode 44 of Games with Go, where we will be working on creating kind of a camera utility that we can use to make it easier to do 3D stuff. Before we do that though, we're going to do some depth testing, and we're going to swap our texture out for one that's a little easier to see than our crazy texture. So to grab the new texture, I'm going to grab metal.zip from the OpenGL subdirectory of Games with Go and save it. And I'll put that link into chat. There you go. And here's the URL if you're looking on YouTube later. It's right there. So let's grab that texture, and we're going to copy it. I guess let's open it up, and we're going to put, I guess, all of this. Let's see. Not that one. These are normal maps. We might do that later. So we'll put all of these in there. We're going to use this metal box full as our main texture. So let's just grab all of this. And pull up your project directory. And we'll just put all of these textures in here along with the credits. This is a texture from OpenGL. That's the user who provided it. Thank you, Luke. All right, so let's go to our code and let's load, what was it, metalbox full.png? Yeah. Let's see what that looks like. All right. So you can see how like it kind of looks like we're seeing inside the box sometimes. Like it looks a little strange. And that's because there's no depth testing happening. So we need to tell OpenGL to do that. And I think all we need to do, well, two things. One, when we set things up, we need to enable that feature. So there is a GL enable function, and you just give it the flags for the thing that you want to enable. And I think it is maybe just GL depth. Let's see. GL depth test. So depth test. And then the other thing we have to do is depth is kept track of with a buffer behind the scenes. So each time you render things, it's filling up that buffer. So just like we're clearing here the color buffer, we need to also clear the depth buffer. So let's give this a try. All right, now we're seeing only the outside of the box, which is what we want. Now you will notice when we go inside, if we move past the front face, that we can see the inside of the box too. Sometimes you don't want that for efficiency. You can turn off the back sides of polygons if they're not going to be visible, or you don't want them to be visible. Just something to keep in mind. All right, so now we've got metal boxes. We can walk around. That's pretty cool. now we're going to start working on a camera utility, and we'll make the ability to use the mouse to look around just like you would in a first-person shooter. Any questions so far? If anyone joined a little late, I'll post the camera or the texture link again. That link has got a texture that's a little easier to see than our crazy procedural texture. Okay, so we're going to build a camera utility, and we'll do that inside of our GoGL project. We'll make a new file called camera. And that'll be part of the same package as everything else, package GoGL. And we're going to make a struct. Let's see. And we'll capitalize it because we're definitely going to export. So we need to keep track of all the things we need to define a camera. So some things are pretty obvious. A camera needs to be in a certain position. And we're going to want our MathGL as part of this. So going back to hello triangle to grab that import MGL 32. And we're going to want to use its vector3 type for some things. So yeah, so we're going to need a position. Which will be a vector3. Now then we need to kind of define how the camera is oriented, which way it's pointed and rotated, basically. And we can do that with a series of vectors. Front, up, right. And we're also going to keep track of what we consider to be up in the world. And then we're going to need to have some floats. So we're going to have a yaw, pitch, movement speed, mouse sensitivity, and we'll do zooming as well. And I did all of those backwards. So I can't do the cool trick that I can in Visual Studio. There's a way to edit that in one block, but I don't know it in VS Code. Okay, so that is it for our struct. Now we just need to make helper functions. So we'll start with sort of a constructor type thing. And we'll take in a position as a GL32 vec3, and our up vector. That's going to be our world up. And yaw and pitch. Okay, so let's make a, let's see, how should we do this? Yeah, let's just make a new blank camera. So we'll say make a camera with everything zeroed out. And we'll set the position. And we'll set the yaw and the pitch. And then we're going to kind of calculate all these vectors based on what we have. Oh, also world up equal world up. Okay, so now we're going to do a function that will take a camera receiver and update all these vectors. Okay. Any questions so far? Chat says that Twitch told me to be polite before typing. Yeah, I think there's a setting that I set to do that. It's good advice. All right. So let's make a, let's see, front. We're gonna make an empty front vector. Let's just do that. Var front is a mathgl dot. Does this have a? Doesn't really do that. Okay, so we'll just make this vec3. So that's going to be zeroed out. And let's set everything. How do I set things? MGL is a little weird with this. I'm going to check and see what the normal usage is for, well, weren't we doing this? Let's see. Oh, that's right. We just use the struct initialization syntax. We can do that. So let's do that. Okay, so we also going to need math. Because we're going to need cosine and sine here. So we're going to do cosine of GL32, convert degrees to radians for our yaw. Pitch. this capital. Yeah. We're going to have to convert these things to float 64s. And then back to float 32s. So that closes the greeter add, cosine. Actually, we don't need this. This has to be a float 64. We need one more. Okay, there we go. That's our front.x. Oh, we've got two more things to go. Yeah, that's our x. And we need our y. And now we need pitch. And then lastly, z. And that is sine. Of yaw. Times cosine it really would be easier just to use radians to begin with, I think. All right, let's see. Pitch, float 64, cosine. Yaw, float 64, sine. Where are we missing one? Pitch, float 64, sine, float 32, cosine, there we go. No. Oh, MGL 32. Camera.pitch. Camera.yaw. Camera.pitch. Okay. It's happy now. Chat asks what matrix library we are using. It is MathGL, which is a pure Go kind of clone of GLM. So this is the library we're using, MathGL. And it's basically equivalent to, what's the GLM? Please no. Okay. The OpenGL mathematics library is basically a port of this in pure Go, so you don't have to use C bindings to use it. And it's a little bit different in some ways because, like, GLM does operator overloading and Go doesn't have that, so a lot of the API is different. But it's got all the same features, but sometimes it works differently. So it can be, if you're used to GLM, it can be tricky to figure out what's going on sometimes. Okay. And now we want to set the camera's front, and we're going to normalize this vector. And what normalize does is it just makes the length of the vector 1. So the relative sizes of the x, y, and z will remain the same, but the total length of the vector will be 1. So we'll do ngl32 normal. We just take it like, there we go. And does that normalize it in place? No, it returns a vec3, so that's what we get. So some vector libraries, when you call normalize, it will just normalize that vector. Others will return a normalized vector. So be sure you know which it's doing. All right, so now we need to get the right and up vectors. So camera.right is 32, ngl32.cross. This doesn't work that way either. So we do camera.front.cross with camera.worldup. So we're getting the cross product of world up and front. And then we normalize that. And camera.up is camera.right. Cross product with camera.front. And then normalize that. I'm just checking in on chat. Okay. So that's it for update vectors. So all this has to do now is return a pointer to a camera. So we're going to return pointer to a camera. Oh, we need to call update vectors. On our camera before we return it. All right. Next, we want the useful function, which is to get the whole point of the camera. Is the camera is going to be something that we can kind of easily modify, right? We can change its position, we can change its orientation, and then we'll get from it a view matrix. And remember, the view matrix is what we use to transform things from local space into, not from local space, from world space into view space. All right, we've got our world with all of its vertices laid out, and we need to start getting that into a two-dimensional space on the screen. And we did that with our view matrix. And we're just kind of building that by hand here and passing that on to the shaders. And we're going to be getting it from the camera. So we need a function with a camera receiver. And it's going to get view matrix. And it's going to return a ngl32.map4. 4x4 matrix. And this should be pretty easy, assuming that mathgl has the same function that it does. So look at is a function that takes a few vectors and gives you back a view matrix. So it's calling them, so it's actually not taking vec3s, which is odd, but that's fine. We can use it this way. Right, so it's basically wanting your the position of the camera. They're calling it an eye in their function definition, but that's the camera position, X, Y, Z. And then we're giving it basically the front and up vectors as well. So we're going to do camera dot position dot x, camera dot position dot y, camera dot position dot z, and then we're going to get we're going to add the front vector to the position vector. So we're going to do a new variable. What did look at want to call it? Center. We'll call it center. And so where were we? Yeah, so camera dot position, add camera dot front. We're going to add those vectors and then pass them. And then finally the camera's up vector. That's a long function call. And that should return a map4. Yeah, so we just returned that. So I think now we can test this. We just have to make a camera. Well, let's try it. Let's go to hellotriangle.go. So instead of getting our view matrix this way, we will make a camera. So we'll make the camera out here. There we go. And it needs a position, world up, yaw, and pitch. So let's give it the position. What else do we need? World up. I think we're going to want it to be just y of 1. Then pitch and yaw, we'll just do 0 at first. So do position, world up, 0. And then down here, we'll just get the view matrix from the camera. And I don't know if this will be pointed at the right place yet. Let's just see if it runs. Okay, it runs, but I think we're not pointed at the right place yet. So what we're going to do is we're going to start taking in keyboard input and mouse input to change the pitch, yaw, and position. So let's go to our camera. Chat asks, why do we capitalize some of your methods and not others? Good question. In Go, the capitalization actually has meaning. Lowercase things are private, uppercase things are public. So in this example, we definitely need getViewMatrix to be public, and we definitely need newCamera to be public, and we almost certainly want updateVectors to be private, because that's something that the camera will manage itself. So it's equivalent if you're in C++ or C# to tagging things public or private. And sometimes, you know, in your actual program, you know, something that's not a library, I'm not always consistent about it, maybe. Maybe I am. There's only one function here anyway, so that's why. And you could always order them so that all the lowercase ones are in one spot. All the private stuff's in one spot. Okay, so how are we going to send our camera input about where we have gone? So let's define directions as enum, and then we'll pass that to the camera. So we'll say, let's see. Do forward, backward, left, and right. And this will be a direction. Okay, so then we're going to do update position, and we'll take a direction and a elapsed time. So delta t with elapsed time. So we'll calculate a magnitude that we're going to move based on movement speed, which we have not set yet. So let's take that as one of our variables. So speed, let's say camera.movement speed equals speed. So camera.movement speed times delta t. All right, that will make the camera move the same speed no matter what the frame rate is, because we're going to pass in how much time has elapsed between frames. All right, switch direction. All right, so we'll have up, down, left, right. And we'll say camera dot position going to add the front vector multiplied by the magnitude. Oh, we don't have up, down, left, right. We have forward, backward. All right, then backwards going to be subtract. And this is going to be subtracting the right vector. And this will be adding the right vector. Okay, so we're going to, in our program, detect keystrokes with SDL and then call update position every time we do it. And then we'll need to also do our mouse. Let's just do update position, just do update camera. That's what we'll call it. So we'll take the direction we've moved in and we'll also take in how much the mouse has moved. So we'll have a X offset and Y offset. So how much the mouse has moved in the X and Y directions. And we'll need our mouse sensitivity to be set. So we'll take a sensitivity variable. Set that equal to sense. All right, so we're going to multiply the X offset by the mouse sensitivity. And then we're going to change our yaw and pitch based on that offset. So yaw will be the X, pitch will be the Y. Camera.yaw. And then we're going to update vectors. Camera.update vectors. All right, so now we need to go back to our program and start using this camera instead of changing things by hand. So we were keeping track of this X variable and Z variable to move around. So we're going to get rid of those. And instead, we're going to, let's see. So we're going to figure out direction. So this is going to need movement speed and sensitivity. What are some good defaults? Do 2.5 and 0.1. Okay. So we're going to have a direction, and if there is a left, then there equals GoGL.left. There equals GoGL.right. OpenGL.forward, backward. And then we'll pass the direction. And we need a delta t. So I'm going to go back to one of our older things where we have a frame rate limiter. Where do we do that? We do that in balloons for sure. 15 minutes left. That's right, we get time.now and then the elapsed time like that. Okay, so where's our start of our loop? So we're going to need frame start time.now, and we'll need to import time. And then our elapsed time this is for 32. No. Okay. I'm going to move this under. All right, so update camera with the direction, the elapsed time, and then we need X offset and Y offset. So we need to know how far the mouse has moved. So again, I'm going to go back to previous project and steal some mouse code. So we don't need the buttons right now. I think all we need is get mouse state. Yeah, so this is going to give us mouse X and mouse Y. We're also going to need previous mouse X and mouse Y to know how it's changed. So we're going to have previous mouse X, previous mouse Y, and we don't care about the mouse button state, so we'll use underscore. We don't care about mouse button state here either. So the offset will just be subtraction. Okay, let's see what happens. Mouse sensitivity might be crazy or something. Nothing's happening. Okay, let's check things. me try some different defaults. Nothing. So let's do some debugging. Let's see if we're calling this properly. So up x, up y, up z, xyz, xyz, xyz. That looks correct. Let's see if update vectors looks correct. So we got cosine of the yaw times cosine of the pitch, and then sine of the pitch, and then sine of the yaw times cosine of the pitch, and we normalize it, and then right is the cross product of front and rolled up, and up is the cross product of right and front, also normalized. So that looks correct. Are we setting everything in here? Yaw, pitch. I'm going to reorder this, doesn't matter, but just makes more sense. Rolled up. Let's see what kind of elapsed time we're sending. Okay, so that's milliseconds. Maybe the mouse sensitivity is so low that I'm not actually moving anywhere. Let's try that. New camera. Oh, wrong file. Let's try 10. Nothing, man. Let's go into update camera. Let's print out the magnitude here. And then do the yaw and pitch here to see how it's changing. So one problem is we're sending a direction every time. So we need another case. We need a nowhere case. GoGL camera. Nowhere. Case nowhere, do nothing. And then start it out at nowhere. So that way update camera is not always going to do something. There we go. We were just running away. Okay, our mouse sensitivity is way too crazy. Need to go back to what were we doing before? 0.1. All right, still crazy. I think something is amiss with the mouse sensitivity. Yeah, our yaw is changing by hundreds at a time. That's not good. Are we multiplying? Yes. Are we setting the mouse sensitivity? Yes. I'm going to print out the Y offsets and X offsets also. There we go. Why does it keep moving? Oh, I think I know why. Because we're setting previous mouse Y and calling camera update, but we're never resetting it. So we should be doing that. Okay, there we go. We're getting it. So let's kill these print lines. That's going to kill our frames. We can't get frags with bad frame rates like that. Don't need format in there anymore. And then let's crank the mouse sensitivity back up to maybe 0.1. There we go. All right, I can look around, but now I can't move. Why not? Movement speed too low. What are we setting movement speed to? 2.5. Oh, I was hitting WASD instead of arrows. We did it for arrows. Okay, that's way too fast. Try 0.2. Still too fast. 0.02. There we go. That's more reasonable. So now we've got first-person shooter style mouse controls. And you can fly around. Pretty cool. All right, that is it for tonight. The goal was to finish the camera. Wasn't sure we'd get it, but we've got it. Cool. All right, so next episode, I'm open to suggestions for what people would like to see. There's various options. Let's just run over some. I guess two options, basically. Main options would be lighting. So right now these things aren't really lit. Everything is just one brightness all the time. But OpenGL lets you create, or we can create a lighting system where we can place lights and things will have shading and so on. Or we could do model loading. So all of our objects so far have been made by typing in vertices by hand. But you can also load up models that have been created by like 3D modeling programs. You can load those in and have more complex models than just cubes. So if anyone wants to vote for one of those two things, we'll do one of those. I'm not sure which yet. Any questions about tonight's stream or previous streams? I'll hang on for a few minutes in case anyone does. So there's some other things you can do. I'm just going to ramble for a little bit while I wait for questions. With the camera, let's see, for one, I want to switch the pitch because it was kind of in reverse mode. Yeah. That's how I like it. Another thing you can do if you want to make it like a first-person shooter is you can limit the pitch. So you can say if camera.pitch is greater than like 90. This just prevents someone from looking more than straight up. And if camera.pitch is less than -90, And this prevents people from looking further than like at their feet. So that just limits things. There's also probably a way to lock the mouse cursor with SDL. I'm going to look and see. How do we do that? Trap mouse. Set relative mouse. That's the function. So let's do that. Because right now when the mouse goes off of the window, then you're no longer doing things, which is no good. Here's our SDL setup. True. There we go. Yeah, so now the mouse is locked to the window. Why is it limiting my yaw though? That's kind of weird. I'll have to look at that. All right, that's it for tonight. Thanks everyone for joining in. I'll see you next time.